Hello, everyone. Welcome to our Future of Data ASEAN virtual event. It's a pleasure to be here with you all. We have a very exciting lineup today. But before we begin, I would like to just introduce you to the agenda that we have. So we have a number of distinguished speakers that will be explaining to you about how data in motion works. And we will have a Q&A session and also a gifting session. But before we jump into the actual agenda, maybe I could do some housekeeping for everyone that you could understand what are the very nice prizes that you could be winning. And if you do have any questions, please feel free to post them into the YouTube channels, and we will take note of them and answer them during the live Q&A. We have some very cool swag for you. You do need to remain within the live system to be eligible to get your prizes. And at this stage, I will introduce to you my two colleagues, Andre, who is based in Australia right now. Hey, Andre, it
Hi,
is
Wayne.
8 p.m. his time, so thank you for staying a bit late. And Manoj
No
is
worries.
based in Singapore. Hey, Manoj, say hi.
Hey, Wayne.
All right. So we're sure to have a great event. So I'm going to now pass it on to Andre, and he will start the session officially.
Thank you, Wayne. Okay. So as Wayne was saying, my name is Andre Araujo. I'm based in Melbourne, Australia. I'm a data motion field engineer in Cloudera, which means that I specialize in products that deal with data in motion, which is what we're talking here today. And I work with the folks in the field, like Wing and Manoj, to help bring these technologies to customers when we need to. I've been about 6 years with Cloudera. I used to be in the professional services team as a principal solutions architect before, and now I can focus on pretty much everything streaming. And I'm also one of the security SMEs at Cloudera, so I try to bring those things together. So today we're going to be talking about streaming best practices, but before we get there, I just wanted to set the context and try to explain why streaming, why do we need streams technology. So in the last decade, and especially in the last few years, we have been seeing an increase in the adoption and implementation of use cases that typically require a very, very fast response time. So things like fraud detection in all different types of systems and detection of failures in mobile phone networks, all the way through clickstream analysis when you want to provide on the fly recommendations for your customers as they click through your website, or you want to gain knowledge from ever increasing fleet of IoT devices streaming data in real time to your data center. Today, we do have the technology that enables us to implement these use cases and provide very fast response times to those. And just because we can, people want to implement them. And this is what we're going to be talking here about today. And later, Manoj is going to do a quick demo of the technologies that we have. So the traditional big data approach to data processing, which involves storing data at rest and then using distributed computing to process data at scale, doesn't cut for these use cases anymore. You can process data with very high throughput, but when it gets to get insight with very low latencies, we need something else. We need to extend our stack to ensure that we have the necessary technology to process data as it comes into the system and before it hits the disk and is stored at rest. So we need the necessary technology to buffer, to distribute, and analyze the data, and allow us to provide the quick response time so that we can act on those insights as quickly as possible. So the data in motion term lends itself to the first best practice that I want to talk here about today, which is keep the data moving, in the sense that we should always strive to process the data before the data is rested on disk, right? So the most naive way of achieving that is what's called the point-to-point request response topology, where every source system is directly connected to the application or to the destination where you want to send that data. In practice, this usually leads to very hard to maintain architectures. So what we call the spaghetti type topologies, where every time you need to introduce a new system in your environment, you may have to implement n number of additional connections and maybe retest all the existing ones that are there. So it's very hard to maintain. And besides this type of complexity, you also have the problem of if the source systems are producing data at a different rate than the applications can consume, then you have the additional complexity of implementing flow control or buffering for each one of the individual connections. So rather than doing that, the best practice is to use a message bus. So when you use a message bus or a pub-sub architecture, applications can connect to the message bus and subscribe to the data that they want to receive. So as the other systems that produce that data to the bus, that information or that data is efficiently and very fast, very quickly conveyed to the applications that want to receive it. The industry standard for this is Apache Kafka, which is it's a distributed system that can process and distribute messages in a very reliable and scalable way. It operates at very high volumes, and it allows you to transfer messages between systems with a very, very, very low latency added by the bus. So this is good, very good for all these source systems that can actually connect to Kafka. But what about the other data sources like legacy data sources or passive data sources that cannot connect directly to Kafka? In these cases, what we do is we add another component to the architecture, which is a data flow management system. The data flow management system allows us to create data flows that can acquire data from virtually any data source and move that data into Kafka so that we can continue to process the data from there. And since we have a data flow management system, which should be flexible enough to not only ingest data, but also do some types of processing of data within our environment, we can also use that to prepare the raw data that has been ingested into Kafka to make it available and in the format in the format needed for the downstream processing that will happen later. The tool of choice for this for us today is Apache NiFi, which is a distributed and scalable system that allows to visually create these data flows that can do virtually anything and acquire data from a ton of different places. And it allows users to visually create these, selecting components from a built-in library of more than 300 connectors and processors to do all sorts of things. We also use Minify, which extends the power and the functionality of NiFi to places outside of your network, to the edge. That could be a remote computer or even the small devices like IoT devices running in the field. So with that, you can virtually connect to any places and collect data from any places and process that in your infrastructure. So Kafka, Minify, and NiFi allows us to get the data as quickly as we can to where the data needs to be processed. And this is like our answer for the first best practice of keep the data moving. And as we decouple applications, as I mentioned, using Kafka, so they don't need to be tightly connected as before, we need to make sure that we keep a catalog of all the data contracts that we have between those applications. And this lends to our second best practice here. And when I say data contracts, I actually mean schemas, which is the word that we know these data contracts by. And schemas are basically a document that describes the format of the data. So the applications that are producing and reading, they agree on the data that they are exchanging between them. So if two or more applications need to exchange data, they typically need to have a document that say, oh, this is the format, the data that we are exchanging, so that the one application can write the format, the data in that particular format, and the other one can read, right? So this schema or this contract needs to be shared among the different applications. There are different forms of doing that. You can save that into a file and give a copy of the file to multiple applications. However, this is hard to maintain because every time there is a change in that schema, you would have to update, how many files you have out there. Or you could also include this schema along with every message that you send to Kafka. But again, this is not ideal because you're repeating this information over and over again, potentially for millions or billions of messages. So that's a waste of space there. Also, applications change over time. And it's very possible and very likely that the format of the data that they're exchanging also changes. Right. So when a schema updates, you would have to notify all the applications of those changes. If you have this schema saved in files and disks everywhere, like this becomes a very complex problem to solve. And if you don't do that correctly, you might break some applications when the schema changes, and some of the applications are not aware of that. So the best practice here is to keep all these schemas, all these contracts in a central place. So there is a service called the schema registry, which was designed exactly to do this. So by keeping these schemas centrally, every time you save a schema or store a schema in schema registry, it's assigned a version number and an ID number and a version number. And with those IDs, you can actually embed those IDs in the messages that you send to Kafka. That doesn't take much space and allows any application that's reading those messages to quickly retrieve those full schemas from this central repository and use them to parse the messages. Besides storing them centrally, schema registry can do validation of those schemas for you. Every time you change the schema, it can ensure that you're not breaking compatibility. So it's an important tool for you to have when you start processing data at scale. So that's our answer to the second best practice, how to keep a catalog of your data contracts. Ensure you have a central schema registry service that can integrate with all your applications and help you keep that information so you're always on top of the data that you have flowing through your systems. And last but not least, I just wanted to have a quick talk a little bit about what we call the streaming first approach. And when to talk about that, we need to understand the difference between stream processing and micro batching. If you look at streaming engines that we have that are available today, like in the market, in the open source community, you're going to see two major approaches. You have systems that do event-driven processing, and systems that are based in a concept called micro batching. So stream processing is what we call the real stream processing. It's event-driven technology that will allow you to process events as they arrive in the smallest time possible, like with a very low latency. So this is the technology that we want when we have time critical applications, and response times are very important for us. This is what allows us to implement what we call like real-time processing. For any applications, for example, that do critical alerting and detection of events like frauds, failures, etc., it's very important that we choose streaming engine that allows us to do event-driven and real-time processing in this way. On the other hand, we have micro batching, which is pretty much a batch process, but with much smaller batches and much faster batches. So by reducing the sizes and the time those batches are processed, like we can process data in near real time. So it's not as low latency as stream processing is, but it approaches that very well. So for critical time-critical use cases, this is probably not the best approach, but it still has its place under the sun. If what you want to do requires like a very high throughput processing and time is not that critical. So if you look at 3 of the most popular and available streaming engines that we have out there, Spark Streaming, Kafka Streams, and Flink, we can talk about the differences in terms of latency and processing. So for example, if you use a Spark, or if you want to, if you have use cases that are not very time critical and you need a very high throughput of process to like plow through a very large amount of data, Spark is probably a very good option for you. However, as you move towards time critical use cases, you're going to struggle to get to that like very low single digit or double digit millisecond response times. So in that case, you'd better off look at different engines like Kafka Streams and Flink. If what you need to do, if your use case need low latency and it's only using Kafka, it's reading from Kafka and writing to Kafka, Kafka Streams can make things easier for you. So it will give that low latency, and it talks very well with Kafka sources and its destinations. If you need more flexibility while it's still having low latency, Flink is probably a better option now. It allows you to, it's a stream first engine. It processes data with very low latency, and it gives you the flexibility to read and write data to a large number of different sources and destinations. Flink is it's a distributed engine. It has a very great momentum in the market right now, in the open source community. Is one of the most active projects in the Apache community. If you measure by number of commits, is I think the top 2 right now of the Apache projects, and it can scale very well. It provides for developers different types of APIs that can get you from the very low level API that allows you to do everything you want to do in Flink to high level API that allows you to write a SQL query and manipulate or query streams of data using SQL language, which is quite powerful. We have a white paper that we published some time ago that goes through more details of the differences between these 3 stream processing engines and why you should choose one over the other. So if you're interested, feel free to download from our website and have a read for more information. So the stream first approach is what you should be looking when you need to implement time critical applications. Flink is, I think, one of the best answers in this area. And it's a very cool technology that you guys should be looking into if you're looking into Spark Streaming. So that completes my small list of best practices here. So I'll switch now to Manoj. Manoj is going to talk a little bit more about what I just said, but with more details, and is going to show you guys the cool bits. Manoj, over.
Thank you. Thank you, Andre. That was a very good overview of the whole platform and what is required to build a streaming use case. So quickly about me, I'm a principal solutions engineer with Cloudera. Been with Cloudera for over 5 years, working with data for over 11 years now. So I work with different companies to build solution architecture for data, cloud migration, streaming, hybrid environments, and so on and so forth. So that's a brief overview of me, and I've put my LinkedIn profile over here. If you want to connect, please reach out over there. So Andre gave an excellent background of the bits and pieces of streaming use cases, right? So why don't we make it real? Let's try to put these best practices into practice and look at a use case and see how one would implement these with all the open source technologies that Andre has been talking about. So for the demo, what we'll use is we'll use a scenario-based use case today. For this particular demo, we'll have data that we simulate, which simulates data from sensors from different. Imagine these are Raspberry Pis running on IoT, end devices somewhere in the world. So these sensors will be generating data in real time. What we want to do is collect the data from the edge in real time, curate the data. We want to analyze the data, make predictions on it, create visualizations on it, and so on and so forth. So we are going to take the whole mile, right from the point of collecting the data all the way till we expose it to a end user by the means of a visualization dashboard, running machine learning and analytics on top of it, and so on and so forth, right? So we'll do that entire ecosystem as a demo today. For the technically inclined, a few more points there is we'll look at stateful stream processing of the data that is coming in through the event hub, which is Kafka in our case. But then this is purely, we are talking about the demo use case itself, right? But when it goes to a real life use case, we'll have different personas of users who are going to consume the streaming platform. And each persona, each user will have a different requirement. So commonly, there are three categories of users that we generally see. So obviously, there is business who do not want to see the nuts and bolts. They want to see an executive view. I want to see a dashboard. I want to see something visual. I do not want to go to a black screen and type queries and so on and so forth. I want something visual. I want to get to my the outcome that I'm trying for in a very straightforward and quick way. The next category is developers who want to develop, streaming applications. Some of the requirements include comprehensive set of tools. I want to do code promotion. I want to do continuous delivery of my project. I want tools that are built into the platform that lets my development cycle run a lot more smoother, a lot more faster than I would do, otherwise, right? So that's kind of category of what the developers generally want. And last but not least, operational oversight of the platform and governance. Obviously, the first thing that comes in is ease of management. Then we talk about unified security model, lineage, so on and so forth, right? So all an operational user wants is, I want governance on the whole platform. I want to set up authorization policies. I want to set up identity and management on all the data sets that I have, all the platforms I have. And I want to make sure it is very easy to manage across the entire streaming ecosystem base. So now let's take a look at the solution architecture for this use case. Right? So there is a lot on the slide, so you don't need to go into each piece right now, but we'll walk through each and every single step and look at that step through a demo. Now, let's start with the far left corner over here. We see the first step is where we collect data from the edge, and then we syndicate the data and distribute it. So Andre explained earlier that Minify is a component that we typically recommend for edge data collection from sensors, from factories, from cars, from trucks, wherever data is being generated at the edge. So we will have Minify agents running there. As part of this demo, we'll simulate one sensor with one Minify agent, but in a real use case, you'll find multiple thousands and thousands of sensors running in different locations. But then when we say there are thousands of sensors running in multiple places, we need a central place to manage them. Like what happens when one of the sensors go out of commission, or I need to publish a common workflow to all the sensors, right? So we need a central management place for that. And that's what we call as Cloudera Edge Management. So I'll quickly open up the portal and show you what it is. But before that, it's basically a central place, a central hub, where we manage, control, monitor the edge agents that are running on different devices, right? So we want to push some intelligence back to the edge. This could be something as simple as filtering out null values, or it could be something as complex as like deploying machine learning models to the edge itself, right? So we will look at the edge flow management solution along with powered by Minify in the backend, right? So we'll take a look at that. The second quick area that we'll look at is Cloudera Flow Management, once again based on Apache NiFi. So it's a no-code data ingestion and management tool. It delivers, data movement, transformation, yada, yada, yada. So long story short, you can look at NiFi as the FedEx for data. It moves data from point A to point B, but also does stuff additionally on top. Like if you want to change your parcel, you want to change your data, transform it from one format to another, etc., on the way, NiFi would be an amazing tool to do that. Last but not least, add-on tool, NiFi registry, where I can store my flows. I can move it from dev to prod. All the code promotion activities, you could use NiFi registry to do that. Right. So that's, I think, the first area within the demo. Let me quickly flip over to my demo screen. And a quick note on the demo itself. We have the Cloudera's data platform installed on one virtual machine on the cloud. So all of this is running on a single server. In a real use case, this will be a distributed platform. There'll be, depending on the workloads, depending on the use case, there'll be a lot of servers running in the backend, but we are doing it on a small virtual machine instance for today. So let me just log in. I'm connecting to the central management portal. We will later look into the portal itself, but for now, look at this portal called as Cloudera Manager as the central place, a central hub where all your data infrastructure is managed. This is not just limited to streaming, but machine learning. All your data-related activities will be can be managed centrally through Cloudera Manager. I will now shift the focus to the Minify part. I mentioned about Cloudera Edge Management, which manages the edge devices. So I moved on to that, the browser URL where the edge management tool is running. Let us take a quick look into the data flow that we generated. So when we go into the data flow itself, what it does at the edge is we first want to consume that sensor data that has been published to an MQTT. We consume that data. We want to, if the data is being generated in a JSON format, so I want to evaluate the JSON paths. I want to understand, we want to be format aware. We want to understand what's within the data rather than just taking it as binary and passing it along. So what we'll do is extract the attributes and filter based on certain conditions, if you want to do any minor manipulation on the data. And eventually, we are going to publish it to a central NiFi server running at a different place. So we are publishing all the edge data from all the sensors to a connection to a NiFi server. So this is quite simple, straightforward, but there are other additional capabilities that you could do here, including things like data provenance. I want to see how the data is moving. What's the edge flow manager doing? What is each sensor doing? All of the heartbeats and all the typical things you'd want to monitor on an edge management solution. All of this is built into this management portal. And I have capabilities from here to publish. Let's say I build a new flow and I want to publish it to the 1,000 sensors I have. So this management portal will be the central place where I can build it and I can publish it to the other places. Now, remember we collected the data from the sensor and I published it to a central place. Now I want to catch it in that central place at NiFi, and then I want to do something else with it. So let's see how we catch that from there. Now I flip over to the NiFi portal, where let me refresh it. If you see here, the first one is a connection from the remote processor group, which is basically where Minify is publishing the data. NiFi and Minify use site-to-site protocol to transfer data securely over the network. So we are going to grab the data through a processor, a remote process group, and I'm transforming it internally and doing some actions on it, right? So we are just capturing it and sending it to this particular process group. Let me see what the processing is all about. I double-click and I flip inside. So the first step is, if you remember the flow that I was showing earlier, what I want to do is collect the data from the sensors once again. I want to update some attributes and publish the raw data to Kafka. It's a very common architecture that all the raw events are generally published to Kafka to be made available for downstream consumption for other use cases. So we use Kafka for that in this particular use case as well. So I get the data and I publish it to a Kafka in a topic we have named as IoT. So I'm publishing it there. NiFi is an excellent tool for error management and flow management and control. So here it suggests that, like, hey, if there is a message that has a failure, that has a error message, what do I do? Should I send a Slack message to somebody? Should I shoot an email? Or do I want to send it to another dead letter queue or something like that? What are the activities that I would do if there is a failed message, right? So we want to automate that, and thousands of messages are flowing in per second. And when I want to do some activities, I basically create an extension to this, right? So to the flow. If I fail to publish to Kafka, this is the action I want to take. So you can create flows for failure cases as well. In my scenario, I'm just putting it into a black hole, but in real use case, we want to publish it to a another error handling mechanism. It could be another flow. It could be a retry to publish to Kafka. It could be an email. It could be anything. But we can do error management, error handling here as well. That's the key part. Now, in addition to doing that, let's say I've created this flow, and I want to publish this to a central repository. I mentioned about developers having the need to have a central place where they manage their flows, they control their flows, they update their flows, and publish to production and other higher environments. So what we use for that is something called as NiFi registry. It is once again managed by the central Cloudera manager, but each flow that we build, we can easily publish it to the central NiFi registry server. In the flow itself, I can do something as simple as version, and I can publish a new version if I've made a change. So if you see here, I'm not made a change. So if I want to publish a change, I just say publish my change from here, and I think and all the newer version of the code will be published to the registry. Let's take a look at, on the registry side, how does a flow look like, right? So I'll flip over to the registry, and I see here that 9 versions of the same flow has been committed to the code registry. All the versions are maintained. So if I were to flip over to an older version of the code, I can easily flip over. If I were to have let's say I published this on a dev environment, but I want to pull the new code or the new flow inside the production environment, I will have an indication on NiFi, and I can go and quickly and easily pull that flow into my production environment, for example, right? So NiFi registry kind of acts as the glue and the connector for the whole dev and DevOps lifecycle. So it's really, really powerful and easy. There are a lot of other capabilities within NiFi. Once again, similar to Minify, you have data provenance, you have a lot of capabilities. But if you don't remember anything, but you want to remember just one point, remember NiFi as the easier way of moving streaming data end-to-end and very secure capability within it. It works across different platforms, across different products. And by default, I believe it has over 320 processors built into it. So Kafka is, for example, one of the processors, but there are 320 other processors that you can consume as of today to consume and publish to different other different locations. Now, let's go back to the slides. Let's go back to the slides and take a next step, right? So we talked about Minify, we talked about NiFi, we got the data from the edge, we got it to a central place where NiFi acts as the data syndication system. We are distributing the data to downstream applications. We'll see what happens next. So we, as I mentioned, I showed in the demo, we are publishing the same set of data to the raw data to a Kafka topic. The Kafka topic is called IoT, and I want to publish that same raw data to IoT. There are quite a lot of tools within the CDP Cloudera Data Platform ecosystem where there are add-ons or additional management tools for Kafka, which makes things a lot more easier. When we talk about Kafka being an event hub for your all your streaming use cases, we want additional management and additional controls on top of it. And these are some of the tools that are very, very important. A quick overview, schema registry, Andre covered it earlier. So we want to have Kafka schema management in a central place. So schema registry is a portal, you can call it API or just UI to manage Kafka schemas. Cruise control for Kafka management activities. You want to rebalance Kafka disks. You want to manage what's going on within Kafka. Cruise control is an excellent tool for that. It is embedded into the CDP Cloudera Data Platform stack. Then the last couple of things. One is Kafka Message Manager. So what it basically entails is it's like a zoom-in view that into what is happening within Kafka. You have producers producing to Kafka. You have consumers consuming from Kafka. You have a physical view where there are multiple brokers in there, and there are topics inside Kafka itself. So Streams Messaging Manager is a view inside Kafka itself, what's going on, and so on and so forth. So we'll take a look at that through the demo. Last but not least, Streams Replication Manager. So the Replication Manager is what lets you build things like active DR sites, active sites. I want to have replication of streaming data across different locations, different data centers, different regions on the cloud. The Streams Replication Manager is what lets you do that. So with that, let me quickly flip over to the demo part for this. So far, you've seen that the data reaches Kafka, right? So let's look at the topic called IoT, which I showed in the demo, and we'll see what is going on inside Kafka itself. I will flip over to the Streams Messaging Manager portal, and I was talking about 4 different views that we have, right? So the producer and the consumer, then the physical view of the brokers, and then the topics view. So it gives you an easy, intuitive UI where you have options to drill down at different levels. Now, for this demo, we were publishing data to the IoT topic. So let me click on that topic called IoT, and we'll see what's going on there. So when I hit the topic called IoT, it says that I have like 10 partitions that have been created. I have about 1,000 messages that have been published to it in the last 30 minutes. And it also talks about the producers and consumers of this particular topic. Now, I want to go one level deeper. Right now, I'm in the executive overview page. If I want to go one level deeper into this topic, I can go into the topics view, and I can get in more information on what's happening within the topic and what's going on. So I can see who's publishing to it, who's the producer, which is basically NiFi. You saw the workflow where NiFi is publishing it. So NiFi sensor data is the producer, which is basically producing to this particular topic. Once again, there are a lot of use cases in here. Me coming from an administrator background, if I were to manage and monitor and look at Kafka, this is the portal for me, right? So this is where I would be able to look into the fine-grained details on what's going inside Kafka. I could jump back to a broker view as well. So as I mentioned, it's a one virtual machine server. So this is just the one broker that we are running. And you can look at all the details within that broker, what's going on, how much data is in, how much data is out, so on and so forth. If, for example, I have multiple brokers and I see that a particular broker is running slow, perhaps it is slowness or any other reason, I could look at the throughput, I could look at the load on the particular Kafka broker, a lot of other things. If I were to jump into a physical view of this broker, like what happened to the disk. I want to see if the CPU is overloaded. I want to see if memory is reaching 90% or something, right? So I have a link to Cloudera Manager. I have a link to logs within Cloudera Manager. I can click that and it will take me into the Cloudera Manager where all of these are, the physicality and physical level of the Kafka brokers are immediately exposed to me as an administrator of the platform. Now, similarly, you can look at producers and consumer group level monitoring. I'm not going to show that in the demo, but you can definitely do that. If I were to use Kafka Connect to move some data, make some connections, you could do that as well. But one other feature I thought I'll quickly highlight is the alerting capabilities. I would first set up a notifier, which is where I say the notifier could be an email, could be an SMS, could be whatever, right? So I want to create a notifier at first. And then when a certain condition is met, I would want to send a notification. So the condition is what we set through the alert policies. An example could be, let's say, a broker, a specific broker. And if the in-sync replicas shrinks, for example, I could immediately say create a notification and send an alert. So I don't have any notifiers now. I have not set up email connections. But once I have it, I can choose that in the dropdown and I save it. So whenever that particular condition is met, I get alerting, I get notification that something is going wrong within Kafka itself. Remember, we talked about error handling within NiFi when the flow is happening. Now we are talking about the error handling within Kafka itself. What do I do when there is a message or a topic that is failed within, or not a topic, a broker that has failed within Kafka, right? So I want to make sure there are conditions set, there are alerts that my management team gets or my operations team gets when there is something that's going on wrong. So that's that. And one last thing that I wanted to highlight here, which I've not enabled, is if I were to set up replication across data centers, across 2 different environments of Kafka, I will also additionally enable an extra option here, which will let us look into the replication part of things. Like, is the replication between my active site, like from my site A to site B, is it happening actively? Are there any failures? Are there any latencies experienced over the network? All of that is graphically visible through the Stream's messaging manager. And last but not least, schema registry, we talked about that. So I'll flip over to that UI. And the topic that we have created for the IoT data is something called a sensor reading. You can create schemas in here. This one is of type Avro. I can manage it with the UI. I can manage, create different forks of it. I can create, like, let's say, for example, disable a version, archive it, create more flows, schema, schema management all in one place, right? The key thing here is this schema registry for Kafka. Generally, schema registries are a bit siloed. Within the Cloudera data platform, the schema registry is for Kafka is visible to the other products, like in the sense that I showed you in the previous example that we are publishing from NiFi to Kafka. So NiFi is schema aware on what the Kafka side of things look like. Now, if I can connect to the schema registry, it can publish to the schema registry. So the schema registry is a central visibility layer for the whole streaming ecosystem. Whenever there is data in Kafka and you want to understand the schema from any tool within the stack, you can look at Kafka schema registry as a central place for that. Now with that, let me flip over to the slides again. Right? So we talked about data collection at the edge. Now we have published it to Kafka. Now I want to enrich that data. We mentioned we want some machine learning and analytics, and I want to publish it over back to Kafka. For that, I will once again flip over to a demo, but this time we want to see through NiFi on what's happening in there. So I created a second flow. So let me zoom out a little bit. The second flow it has 2 parts to it. Right? The first one is where we take the data from Kafka, call a machine learning model, and then publish the updated data into Kafka again. Into another topic, we call it IoT enriched. The second extension to that is the same one. We take the data from Kafka, the raw data from Kafka, run a machine learning model, publish it to a real-time store. Apache Kudu is a very good real-time store. It allows you to update your data. It allows you to read and write the data in real time. So if by definition, streaming data, you would not want to have too many layers, but in a lot of use cases, you may want to store the data to disk. For example, you want to run a BI query in the future, or in addition to doing things in streaming, you also may want to write it down to a real-time store. So in this scenario, we are using Kudu, and there is a built-in processor with NiFi where I just drag and drop it, and I say, like, hey, take that enriched data, put it into Kudu, and put it into another Kafka topic. So this is where we kind of have 2 parallel streams of work. One is real streaming from Kafka. I want to run a Flink job to do some aggregations and create some reports on it. A continuous SQL job on top of it, I want to run on top of Kafka. In addition to that, I want to write it to disk, and I want to run a business intelligence style query on top of it, right? So this NiFi flow is doing 2 of these. One item I heavily glanced over is the machine learning part of it. So we're using another tool here, but imagine that this could be anywhere where you've published your machine learning model. We're using Cloudera Data Science Workbench for that. It allows you to do end-to-end machine learning, right from data exploration all the way to putting models into production, making it available via an API, metrics, monitoring, dashboards, and so on and so forth. It's a very comprehensive tool. But for the sake of this demo, imagine a machine learning model is running somewhere. It is served as a REST API. You want to send the Kafka messages to that particular machine learning model, which will predict if that sensor will fail or not. And that will update the source data, and we get a enriched topic where we publish the data. That's the IoT enriched topic that we're sending the data to. So, so let's flip back to this, right? So we now know about the data collection part, the event hub part. Now we want to look at how do I do streaming analytics. I want to run, event, stateful stream processing on the events that are in Kafka. But then not everyone loves to write Java code. Not me. I love to write SQL. I love to write scripts. So if you want a SQL layer on top of it, there is a tool called SQL Streams Builder. It's a very powerful interface for creating stateful stream processing jobs through SQL. Right? You can simply declare things like an expression to filter, aggregate, or even route or mutate streams of data. And you can create things like a materialized view, and all of this is possible on continuous SQL on streams, right? So it's a very powerful tool. And last but not least, it will also allow you to make the data available via a durable data API. So what we'll see in the next part of demo is we are going to consume the data that is published to Kafka, the enriched data that is published to Kafka. We'll create a SQL Streams Builder job, which under the hood is going to run a Flink job. We will process the data. We will do some aggregations on top of the data, and we will make it available via an API call. So that's the next part of the demo. For that, once again, let me flip over to my demo screen. And I will open the SQL Streams Builder portal. Now, when I get to the SQL Streams Builder, there are various functions in here. There are a lot of capabilities within SQL Streams Builder. But what we will heavily use for today's demo is the materialized view capability within here. If I were to run SQL on data that is sitting on Kafka, I think the first key thing that we'll have to do is create a virtual table on top of it, right? So I could call a source. In this scenario, we are connecting to the CDP Kafka endpoint. Maybe I'll just call it as test. That's a virtual table name. It will, once we connect to a specific Kafka environment, it will list me a list of topics within that Kafka environment. So I could choose, let's say, for example, the IoT enriched topic. You can choose different data formats. And I could connect to the schema registry or let SQL Streams Builder automatically detect the schema of the particular topic, right? So the moment I hit Save Changes, I will be able to query a table called test, which in turn is streaming data that is actually that's actually streaming into Kafka, the topic called IoT enriched. I've done this earlier. So if you see here, IoT enriched data, I've created a virtual table called IoT enriched source new. That's basically a random name I gave, but your data is now available. The streaming data is now available as a SQL query. Internally, it is going to publish a Flink job. So we are going to call Flink in the backend. Anything that I'm running in SQL, it's transforming it into a Flink job. All the transformations, all the aggregations, processing that I'm doing, it's going to publish and it's going to run and send it back to me. You see that the data this is actually real-time data. I'm just doing a select star. All the new data that's being generated, it's publishing to me in real time on my screen. So if I were to put it to a dashboard, it would be as simple as that, right? So if I were to write this to a destination, let's say another Kafka topic, let's say another storage, I would create something called as a sink virtual table, and I say, where should I write this data to? And I could, for example, create a topic inside Kafka and add it to it itself. But for now, I'll stop this. I will go to the original demo part where we were looking at creating a materialized view, right? So once I have a job, something like this, I would like to, let's say I want to create a materialized view. I will flip over to the materialized view tab and create multiple, give additional details on it, and also make it secure by giving an API key. For you to access the API, you need the API key, and I've created one previously. So when I create a job and I want to publish it, I would access it from there. So now, for this particular IoT demo, the data is being processed by a SQL job, a Flink job, two Flink jobs actually. So what we're doing is we got the data from NiFi. We are taking the enriched data from NiFi. We are aggregating it for a particular sensor. So in this scenario, I mentioned earlier that we have 100 sensors that are publishing data. We're taking data from sensor 6, we're aggregating it, and then we are creating a materialized view on top of it. So if you look at the aggregate job, it's a SQL query once again. So we're doing things like average of a particular sensor's reading, sum of a sensor's reading, finding count, something simple, but you can go crazy. You can fit any type of aggregation that you need for your particular job and put it into the materialized view. So SQL Streams Builder runs a Flink job, materializes it for you, and makes it available for downstream consumption. Please also remember in the slides, we showed that let me flip over to that. Yeah, we also showed that NiFi is copying 2 copies of the data, one to the streaming, the one consumer is the streaming analytics platform, SQL Streams Builder. The other one we are writing down to disk, right? So that's the other part. What we'll see next is the 2 last parts, the consumption layer. The first one that we'll see is for a batch or on a real-time store, but I want to run batch queries or queries on the data that are getting streamed into the storage in real time. So we'll flip once again to the demo screen. I use Hue for that. The storage I mentioned is Kudu, so we are going to stream to Kudu, and I will run a query on Hue to consume that data. So if I'm a BI user, business analyst, if I like running SQL queries all day, and I want to run queries across batch data and streaming data, Kudu, Impala, these are all great tools to do this kind of use case. So right now I'm using Impala on Kudu to run the queries for that. So as simple as that, I mentioned we're writing to Kudu. The table is called sensors, default.sensors. So I could run there is a typo. Okay. So if I run something as simple as a select star query, I can see that the data is coming in, right? So if I were to figure out like, hey, is the data really coming in? Maybe I should do a count star, see what's going on. So if you see here, there are about 462 something thousand messages that are coming in. So I could, once again, if you see here, the count of the messages goes up. We are streaming data in real time, and we are writing it to the real-time store and then consuming it after that. So data is getting updated frequently. There are a lot of capabilities in here itself. Everything that a BI user would generally want is here, but we're not going to focus heavily on that for this demo. But we'll want to flip over to the other key part of the demo, right? So which is where we'll talk about the visualization part of it. So far, everything is technical view, right? So I mentioned one of the categories of user is the business user who wants to look at visualization, who wants to look at graphs, who wants to look at a powerful dashboard, to look at the whole use case. They do not want to run a query. They do not want to run much of anything else. So look at, sorry, flip the wrong slide. So if you look at this, I mentioned earlier that we have a machine learning tool, Cloudera Data Science Workbench. I've deployed a visualization engine into it. It's called Cloudera Data Visualization. And that's a powerful dashboard. You can create visualizations for streaming data, batch data. You can visualize your models, machine learning models, and so on and so forth, right? So the outcome of your machine learning models and so on and so forth. So let me flip over to the demo bit for that. So mention the central place, the Cloudera Data Science Workbench is here. So I connect to it. In here, I have 2 different things. The first one is the machine learning model itself. It's a model that's running in here. It's been deployed, I believe, like a couple of days ago. So whenever I call this model, it basically says if a sensor fails or not. We saw that NiFi is calling it and enriching your data. But what we want to see right now is the visualization part of it. So let me flip over to that. So this is the Cloudera Data Visualization Tools homepage, right? So I've created what is called as a visual app, an application within it. We have 2 to 3 different key areas where we are visualizing it. This is just a naive attempt at beautifying it. You can customize it for your organization. You can call it whatever you want. But I've just made up a name called Monitoring Tower. I want to see all the sensors in the central place for a business point of view. So the first one is the real-time store view. So if you remember, I ran a query on Hue where data was sitting on disk. I want to correlate across batch data and real-time data as it is streaming in. I want to query data that's really on disk. Again, you don't have to write to disk. That is one of the options, one of the patterns we've seen many companies do. But in case you have some data on the disk, this is a really powerful way to kind of visualize it, right? So the same queries I ran through that Hue dashboard, or similar queries that we ran through the Hue dashboard, this particular portal through Cloudera Data Visualization Engine, it's running in the backend. It's running an Impala query to Kudu and visualizing it. Each of the data point here is a query back to the backend engine. So things like how many total readings are there. Out of the reading, if you remember, we ran the machine learning model to predict if a sensor is going to be healthy, unhealthy, it's going to fail, and not going to fail, and so on, right? So the predictions are being like shown here, some nice graphs at a single each sensor level. You have some powerful graphs here, or simple graphs here. So business users usually care about something like that, right? So the real-time stores visualization is out here. Now the next part is we saw SQL Streams Builder. When data is coming in real time in Kafka, we're running continuous SQL queries and making that available via a API call, and we have a model API key and so on and so forth, right? So I want to collect data from that API, and once again, I want to give a business dashboard for you. Note that within SQL Streams Builder, we did the aggregation job. We ran the aggregation job for one of the sensors, which is sensor 6. So this graph is specific to that sensor. So I clicked on the continuous streaming SQL dashboard. Again, you can customize the visualization engine as you want. I think the capability is what we need to focus here, what businesses generally need, right? So the dashboard can be like up to your imagination, up to your use case. So you can look at different metrics. Once again, all of this is updated in real time. This is we are accessing the materialized view that we are creating through the stateful stream processing engine. Like Flink is writing to a Flink through SQL Streams Builder is writing the states to a particular disk, particular location, and materialized view, and we are consuming it and dashboarding it out here. And the last bit is you don't just have to visualize data based on this, right? Sometimes in real life, you'd have to pull data from several different systems. It could not even be a streaming use case. You may want to pull in data from a completely different third-party solution. You want to put it into your visualization engine. So the Cloudera Data Visualization Engine gives you the central place where you can connect to other external engines or external data sets to visualize some data. Now, these are sample data sets, but imagine you could connect multiple visualizations and create a powerful dashboard, a central control tower, for example, for a specific use case. And last, I will flip over to the slides. So one layer which we'll not see in the demo, but you've seen me touch here and there, is the layer that connects all of everything that we saw today. So you saw me flip from Cloudera Manager to almost every single product that we saw in the demo today. So that will be the central management platform, central management product through which the whole ecosystem of tools run. And these are just like some of the tools. There are various other tools that you can manage through the platform. What makes this a lot more simpler and easier to consume is that all of these tools that I showed, they follow a single unified security model. The authorization is through Apache Ranger. The lineage, the governance is through Apache Atlas. And these are tools that connect together all of these products, all of these tools, and makes building a business use case a lot more simpler and easier to do. We're not doing a demo for that once again, but you can look them up. You can reach out if you need to talk more about these solutions and so on and so forth. With that, I want to follow up. I want to pass it on to Andre for the next steps. Andre, over to you.
Hi, sorry, I was on mute. Typical error. So we're gonna move now to our lucky draw. And if you have been watching and not looking at the YouTube chat, please put your name in the chat if you haven't done so that we can put your name in the lucky draw hat. And I'll switch my screen to our automated super raffle name picker. So we have 4 people, 4 runners for the prizes. So I'll choose the first one, and the winner is Satabdi Patra. I hope I pronounced your name correctly. If you are online, could you please just say hello on the YouTube chat so we know you're here? Satabdi, are you there? No. So yeah. So I'll. Satabdi hasn't replied, so I'm not sure he or she is here. So I'll pick another name. So the next winner is MC Cat. So MC Cat is in the chat. He just posted to tell me that I was on mute. That's good. And we have our second winner now, since Satabdi hasn't replied yet. Yep, so I believe they're not here. So let's get the second winner. And the second winner is Surendar. So Surendar, yep, Surendar is here, and MC Cat is here as well. So good. You guys have won the Cloudera bundles. And to make sure that you receive your prize, let me go back to my presentation here. We're gonna be get in contact with you guys to get your details. So if you could please email your details, send an email to azion@cloudera.com. We'll get in contact with you to get your address and all the details needed so that we can mail those gift bundles to you. So with that, I think we can move to the Q&A. We have a few questions that have been asked and we haven't answered yet. So let me have a look at them. We can take those on. So the first question was from MC Cat. Could Kafka be used for micro batching, processing historical data? Yes, definitely. So Kafka actually doesn't do any processing. Kafka it's a message bus that can be used to exchange information with between different applications. So what you're gonna, and you can use that for anything. You can use for stream processing. If you have data retained in Kafka for a long period of time, like you could store a lot of historical data in Kafka, you can read all that data in batch and process it as well in batch. What's going to do the processing, though? It's the streaming engine that you're planning to use, right? So you could be using Kafka Streams, Link, Spark Streaming, and those platforms have support to both streaming processing as well as batch. So, so yes, you can use Kafka for any of those type of processing. So there is another question from Satabdi, who are asking, could you please show how to collect and curate data? I think, so this question came earlier in the presentation. It was before Manoj started his demo. So I believe part of that, or this has been answered throughout Manoj's presentation. but I'm not sure if you're looking for any more specific details. Do you have anything to add, Manoj, or?
Andre, I think you're spot on. So we showcase some of the tools we generally use to collect and curate data. I think the first thing there is where we need to collect the data. Do we want to collect the data from the edge? That's the first part. We talked about Minify and the edge management solution where you can collect data from the edge. But then when we talk about a central place where we curate the data, you pre-process the data, you want to do kind of transformation on data that is streaming. We talked about Wi-Fi and flow management on that. These are common tools, and then we'll have the rest of the ecosystem to come into picture. But Radesh, right, we covered some of that earlier in the session through the demo. But if there are specific questions, happy to take it up.
Cool. Thank you. So there is another question from George. He was asking, can Cloudera handle real-time streaming data on the public cloud? Who all do you support today? So yeah, absolutely. Like the Cloudera platform includes supports Flink, Kafka Streams, and Spark Streaming as options of streaming engines. And all of those three engines are supported in all the deployment form factors that we support. So you could have that on-prem. If you prefer to use in the cloud, you can connect to our CDP public cloud portal and launch, for example, a Flink cluster or a data engineering cluster with Spark, and use those engines to process data in a streaming fashion.
And I believe there is a second part to the question, who all do you support today? So I believe the question is referring towards the CSPs, the cloud providers. So the answer to that is we support all three major cloud providers today. And you can basically run a hybrid multi-cloud platform with Cloudera Data Platform.
Do you want to take this other question, Manoj? Does Tableau support Hadoop integration and real-time dashboards?
Yep, I can pick that up, and feel free to fill in if I've not answered it completely. So I think the answer was, the question was asked by Chi Kong. Sorry if I mispronounced your name. So so Cloudera's ecosystem of tools is it's a platform, right? So there are wide systems of tools where each tool could cater to a different type of use case. So there are tools where, for example, Impala that I was showing earlier, these are business intelligence type queries usually find its way to Impala. So these are generally places where we see tools like Tableau use JDBC, ODBC connectors to create visual dashboards on top of them. Real-time dashboards with Tableau, I'm not very familiar with it. I've not seen that being used personally, at least. But another example that I would say, or another important point I would say, is I think end-to-end integration, in the sense that the visual tools that we generally use, if it is aware of the security protocols, if it is aware of the identities that we set up for, for example, a SQL Streams Builder job, it would be easier to integrate with that visualization engine. So the one that I was showing earlier, Cloudera Data Visualization, is integrated into the stack, which is aware of all the security protocols in there. But the specific question on Tableau and real-time dashboards, I'm not familiar with the answer. Andre, would you know, or we have to plug that for later?
Cool. Thanks, Manoj. Are there any other questions from the folks watching? We can do some real-time processing on questions as well. So if you want to ask now, we can ask as they come. If there is not any questions in a bit, we'll probably wrap up the session. Okay. I think we have run out of questions. So thank you guys very much. for staying with us until now. Surinder and MCCat, please don't forget to send the email to Azion at Cloudera. Oh, so there is one question here. So what can be used for real-time stream data visualization? Manoj, you have been doing some work with that, so do you want to talk a little bit about this?
So Cloudera's recommended solution for real-time streaming data visualization is using Cloudera data visualization. Basically, the one that I showed in the demo earlier today. So if you're familiar with a company called Arcadia Data, that's an acquisition that Cloudera has made in the last year and a half, I believe, a year and a half ago, I believe. So this visualization tool has been added as part of the Cloudera's ecosystem of tools. It is embedded into different use cases, embedded for different use cases within the Cloudera stack. Common use cases include visualization of streaming data, machine learning, even for business intelligence and data warehousing type queries. So that's one example. That's definitely the recommended option from Cloudera. Additionally, I believe there was a question around Tableau. There are several other tools that can connect to the Cloudera's platform and visualize the products. But what is important to note is all the APIs that Cloudera has, with all the tools that we have seen so far, we expose it through industry standard APIs, right? So REST APIs, JDBC, ODBC, all the industry standard protocols. So any tools that can connect to these standard protocols will work very well. So the recommended solution I once again mentioned is Cloudera data visualization, but any other tools that talk these protocols can work. I think that's all the questions, Andre. Hey, you're on mute again.
Oh, sorry, again, keep doing the same thing. So thank you all very much for staying with us here. Thanks, Manoj, as well, for presenting the demo today. And I was saying before to MCCat and Surrender, please don't forget to send the email to azian@cloudera.com so that we can send your prizes by mail. Thank you all, and have a good night.
Thank you all. Thank you, Andre. Have a good evening.